All right, so continuing with what we were doing yesterday, I'm going to break this into a couple parts. We'll just go through a couple examples today, and that might be it. And then so a couple things I want to do. So I want to practice analyzing quadratic functions in standard form, right? That's first priority. Then after that, I want to look at some additional topics that I don't, just kind of special topics for you guys for the honors class. We're going to look at doing some, remember the regression stuff we did with lines, linear regression stuff? So we're going to do something similar. I want to show you how you can do regression for quadratic functions. It's real similar, okay? And then how we could use that to do, there's some technology tricks you can use that are really handy that can eliminate some work. You could do a quadratic regression or a quadratic fit with 3 points. We'll talk about that. And then I want to look at some applications. Finally, when we start getting to quadratics, we can start to do some things that are a little bit more interesting. There's some applications that are kind of cool applications. You can actually start to do a little bit of math that means something. So we'll look at that. I know we won't get to all that stuff today though. So that'll be for today. And we either take, would you rather have a work day tomorrow or Friday? Tomorrow? Let's vote. People would rather have work day tomorrow than Friday.
Well, what would we be doing on the other day?
The other day, we're going to continue on with this stuff. Okay, so put your hands up high. How many people would rather do it tomorrow? How many people would rather do it Friday? Ooh, 1, 2, 3, 4, 5, 6, 7. So Friday seems to win, I'm thinking. Okay, all right. Okay, I think that's probably better anyway, honestly. I think that works better. Okay, so what about this then? We want to graph this function f of x. We want to do a bunch of stuff for this, and these are just like the problems that you've got on the assignment. The assignment is up now for this too. The assignment's in 2 parts. First part is just going to be doing these kinds of problems. Second part's going to be all that other extra stuff I was talking to you about. Okay. So what would we do here? How am I going to find the vertex? You remember from yesterday? You got to find h and k, don't you? What's the formula for finding h? Negative b over 2a. There you go. Good. So we got to determine what are the values of a, b, and c then. What are they? A is negative 2, b is, c is negative 10. Good. And we know h is negative b over 2a. So that's giving us, what's negative b? 12. Over 2 times negative 2 is negative 4. So what's h? Say it again. Negative 3. Good. We got. Hey Jackie, can I give you a call back in just a little bit? Awesome, thanks. Bye. Okay, so h is negative 3. How do I calculate k? Yeah, f of h. You gotta plug it in, right? Anytime I want to calculate a y value, I have a function. I'm just going to input the x value to calculate the y value, right? So k is f of negative 3. So I'm just plugging it into my function. So that's going to give me negative 2 times, instead of an x, I've got the quantity negative 3 squared minus 12 times negative 3 minus 10. So what's that giving me? 9. See, this is good mental math practice. See if we can crank this out mentally here. So I'm getting positive 9 times negative 2 is negative 18. Minus 10 is negative 28 plus 36. Eight's right. Okay. So k equals 8. So what's my vertex then? Negative 3, 8. There you go. Okay. Right? And so negative 3, 8 is, where is that? So negative 3, positive 8 is right about there. Okay. The table is, I don't think you even want it. You can use it, but that's kind of a lower level thing. We can do this a little slicker. We can be a little more subtle about this if we just use A instead, right? It's a lot quicker. You don't have to go plug a bunch of values. I mean, it's not easy to, when you have a quadratic function like this, to go plug a bunch of values into that, is it? I mean, you got to do a lot of calculating to come up with each output value for every input value. So we can do this, we can be a little smarter about this. If A is equal to negative 2, that's our vertical dilation factor, right? So what's that tell you about some points that I can use to graph this parabola? And let's go ahead and just make a vertical line through our axis of symmetry that's going to split this thing in two through the vertex, right? So there's our axis of symmetry, right? If A is equal, I keep going down too far. If A is equal to negative 2, that gives me a roadmap to another point other than the vertex. What would it be? I'll get you started. Like if I went over 1 from the vertex, what would I do? Say it again. Down 2, right? How come? You're right. How do we know that? See if you can articulate an answer. That's it.
Multiply the output by the dilation factor.
Okay, good. So the dilation factor is negative 2. So we'd be multiplying apparent height by that to get our dilated height, right? So normally with our parent graph, we would go over 1 and up how far? 1. Okay. Normally we'd be going over 2. Oh, darn, I gotta do this. We'd be going over 2 and up how far? 4, right? Because we're going up 2, that number squared. It's y equals x squared is the parent graph, right? So over 2 and up 4, okay? And that's how I'm creating this parabolic shape. We're multiplying the regular parent heights by our vertical dilation factor to get the dilated heights, of course. So instead of going over 1 and up 1, we're going to go over 1 and up 1 times negative 2, right? Because that's our vertical dilation factor. So good. I just want to make sure, you guys all knew what the answer was. I want to make sure you just remembered why. So over 1, down 2. Over 2 and down how far? 8, right? Good. Over 2 and up 4 times negative 2. So where's that take me? All the way down to there. And then I always get 2 for the price of 1 with this stuff, right? I can reflect those over my axis of symmetry to get free points on the other side. And we got it. Right, so there's my graph. Okay, good? All right. What's the axis of symmetry for this? Okay, what's the axis of symmetry? What's my formula? X equals?
Negative.
Say it again. Negative 3. Good. Just the x coordinate of the vertex. Good. What's my domain for any quadratic function? all reals. Okay, now how about the range? We don't even need the graph for this, right? Does the parabola open up or down? I mean, you know it now, but based on A, it opens down. So the vertex then is a maximum or a minimum?
Maximum.
It's a maximum, right? Does that make sense? Maximum means the highest value of the function. So a maximum is always going to look, and this is what we do, a lot of this in calculus, we're looking for maxima and minima. A maximum, when I graph it two-dimensionally on an XY plane, always looks like a peak, doesn't it? Right? And a minimum looks like a valley. Okay? So yeah, this would be a maximum. And so what would the range be then? If the vertex has coordinates, and let me put those on there. There's the vertex, right? What would the range be? Y is what? Less than or equal to 8. Good. And so in interval notation, just look like that, right? Notice I got brackets around the 8 because we're including the 8. Okay? Function is increasing on what interval? Increasing on what interval? Everybody get that? Right? Because it's opening down, the function is increasing on the left of the parabola and decreasing on the right of the parabola, right of the axis, right? So that would just mean all the values, it's increasing for all values less than 8, which we would say like that. Or sorry, I said 8. What did I do wrong? I picked the y value, right? What do I want to pick? The x value, of course, right? Yeah, we're wanting to know, based on the inputs, for what input values is the function increasing. That's a common mistake that I just made, right? That's the one we're looking for. We're comparing it to the axis of symmetry here, right? X equals -3. So then it would be decreasing for values of x greater than -3, which look like that, right? Okay, give me 1 to 5 on that. How are we doing? Okay. Okay. All right. Okay, let's try one with a fraction in it. And then that's probably good. I'll let you work. You want to take a second and work on this one on your own for a second? Try it. So first step is get the values of A, B, and C. Convert those to H's and K's too. And then we'll come back together and take a look. Not done yet. Okay, so let's calculate H and K. Well, what's A real quick? Okay, so then H is negative B over 2A, right? So what's that fraction going to be? Negative B is going to be 7 over 2 times -1/2 would be, aha, okay. So H is -7, good. Now K is going to be a pain. That's not going to be fun to do. We got to plug, oh my goodness, that's bad, huh? So then K equals F of -7. So that's going to give me -1/2 times 49, right? Okay. Minus 7 times -7 minus 41/2. All right, so that's giving us -49/2. We can be smart about this. -49/2 minus 41/2 is, okay, good. So we're getting -90/2, which is -45. and then minus a negative is plus 49. So what do we get? 4.
That was way more simple.
I know.
Okay, so we get the ordered pair then. Negative 7, 4 would be our, right? Okay. All right, let's go back to here. So that makes sense? Negative 7, 4. The axis would be x equals negative 7. Good. Domain is boring. All reals. The range. What's the range going to be without graphing it? A is negative, right? Okay, so what's it going to be? Y is less than or equal to 4. Good. So that? In interval notation? The largest open interval over which the function is increasing. Don't make my mistake. What's it going to be? What's the largest interval if this is opening down where the function is increasing? All values of x what? Say it again. Less than negative 7. That's it, right? Because the ant has to be walking uphill towards the maximum from negative infinity, right? Okay? And that's the negative 7 is the x value of the vertex. So yeah, there we go. X is less than negative 7. And then it must be decreasing when he's walking down the other side when x is greater than negative 7. Okay? Now let's graph it. So we got our vertex. Our vertex is at negative 7, positive 4. Ooh, yikes. Negative 7, positive 4. This is not very convenient. But there it is. Right, there's our vertex. What's the shape going to be? If we said A was equal to negative 1/2, right? Yes. I did. Thank you, though. I did. Thanks for the reminder. So we said A was equal to negative 1/2. Allie forgot her job. So what's going to be my roadmap then? Let's try to pick a really good one. Instead of going over 1 and up 1, I'd go over 1 and up how far? What would I do if I went over 1? Down a half. That's not very convenient, is it? Okay, so what's a better one? Oh, okay, over 2. Normally, if I go over 2, I would go up how far? 4. So what am I going to do instead? Over 2 and down how far? 2, right? Because I'm going to multiply 4 times negative 1/2, right? Okay. Does that make sense? Okay. I got some different answers there. Does that make sense?
Not really.
Okay. So how do we find? So I think where there's a little bit of maybe some misconceptions. Maybe people aren't totally clear on how we're getting these dilated heights. Right? Remember what our formula is for this. When we want to calculate dilated heights, it's really simple. And what is a dilated height, right? Those are the heights of f of x compared to our parent graph, just x squared, right? So the dilated height is always equal to a times the parent height. We just want to pick a convenient point on our parent graph that's a convenient height for us. Right? A height of 1 wasn't very good because in this case, a is negative 1/2, right? So we want to pick a height that's compatible with the fraction negative 1/2. So over 2 up 4 would work, right? So if we pick that height, my dilated height then would just be negative 1/2 times 4, which is negative 2. Okay, That help? Okay. So over 2, then we're gonna go up 4 times, can't read that. Oh my goodness. What did I do there? I never know. Did I hit, what the heck? There, that's where I want to be. I don't know what I did. I have no idea what I just did there. So 4 times -1/2, right? Okay, so here's our point then. I can flip it over to the other side, but I don't really, in this case I can't because it's off the graph. Here's my axis of symmetry if I want to move that over right there. And something like that. Okay? Good? All right, it's probably good for today. You can, first assignment is just practicing that stuff. So jump into the first one. That's 3.4 practice 1.